Hello everyone. So this is the last Volcanoes Lab. It'll be lab 8 overall. So I'll hop right into it. So the lab mentions 3 different rock types. They're sedimentary, metamorphic, and igneous. But for this lab, we're only concerned about igneous because those are the ones that are formed at volcanoes or deep in the earth by magma. And then igneous rocks are defined by their textures. So just kind of how they look. And these textures are the result of either crystals or bubbles typically. So for instance, this one on the left is very, very crystalline, just all these like speckle patterns to it. These are all crystals just tightly packed together, versus the one on the right has all these bubbles typically formed by air bubbles when the rock cools really quickly. So they're both igneous rocks, but they obviously look very different because they have very different textures. So then 2 kind of subcategories of igneous rocks are intrusive and extrusive rocks. And the way I remember them is intrusive has the word in it. And these intrusive rocks form in magma chambers. They do not erupt. They cool over very, very long periods of time. And with this, because it has a long time, it is able to grow these really large crystals. And we can often think of these crystals like tree rings. If you give it enough time, they'll slowly build out. But on the other side, extrusive rocks kind of sounds like exit. These are rocks that actually did erupt. And because they erupt, they cool really, really quickly. So it doesn't give the rock any time to form these crystals. So they'll often be smoother like this. And some of them will have air bubbles depending on the composition. And then I find these 2 rocks to be good examples because these 2 actually have the same composition. They have the same chemical composition, but they look very different because one's intrusive and the other's extrusive. This guy on the left is a granite, so like granite countertops. And then this guy on the right is a rhyolite. So same composition, the only difference is this granite cooled really, really slowly and never erupted. And this rhyolite cooled really, really quickly because it did erupt. So it didn't have time to grow those same crystals a granite could. Okay, so figure 1 is looking at a plagioclase crystal, which is really common in igneous rocks. And we're looking at zoning, which is when these rings form, which is really common to tree rings. And they form depending on the composition of magma. So similar to tree rings, kind of just depending on your environment, different rings will form. If you have like a really rainy season, you'll have really big rings that you can see really well. And if it's like a drier season, not so much. Kind of the same deal, just depending on your chemical conditions, your rings might be really easy to see or not so easy to see. And then you can change these chemical conditions by just changing the system. For instance, like adding new magma could form a new ring. And so the lab is going to have you count these rings. So looking at the blue line, just each kind of ring that we see in here. And it's a little hard to see, so I'm going to accept a range in answers for this, but give it your best shot. And then question 4 is going to have you measure half of the crystal because we're trying to get at how long it took this crystal to form, and it's forming the same on both sides. So kind of in theory, we can just measure half of it and get at that answer. So just measure from the center over to the edge. And then we have a scale bar here in centimeters. So your answer should be in centimeters. And then we can use what you measure there to get how long it took that crystal to form. And you would take that measured distance in centimeters and divide it by 0.043 centimeters per year. This number is a constant that we get in how long it takes this plagioclase crystal to form. So take your distance, divide it by this constant, centimeters would cancel out, you're left with years. And then question 7 is asking how many years each stripe represents. So to do that, you're going to measure the blue line in centimeters, and then do the same thing. You'll divide it by 0.043 centimeters per year. Centimeters will cancel out. You'll be left with years. And you can take that total years, that would be the time it took just here to form, and we can divide it by the number of stripes within here, which you should have gotten for question 3, just the number of stripes along this blue line. Okay. So some common igneous rock textures that we'll be looking at. Vesicular rocks are when they form these holes like this from gas bubbles when they cool really quickly. Crystalline structures are just made up of all crystals, like this guy, really packed structure. Porphyritic textures are kind of a mix. Crystals started to form. We might have some small crystals in here, but then kind of in the process of cooling, it erupted. So it halted that kind of growing crystal formation, and it kind of just froze it in time like this. And then glassy has this really shiny, glassy look because it cooled really, really quickly. We don't really see these individual crystals in it. And then I'll say a quick word about porphyritic versus glassy textures, because they can be a little confusing. Porphyritic textures, they often have small crystals that we can see, but it gets a little confusing because it does have some glass in it. But overall, I wouldn't call it glassy because we still have crystals, and it lacks that shiny look compared to what a glassy texture would have, which is all smooth and shiny with no visible individual crystals. And I bring this up because the lab gets a little confusing. In the middle part, we have different rocks for you here, and we ask you to identify like which one has a glassy texture, which one has a crystalline and porphyritic texture. And just because a picture says the word glass doesn't mean it's glassy. If you can see crystals in it, I wouldn't call that glassy. I'd probably call that porphyritic. It would need to be smooth to be glassy. Yep, and then the last part of the lab is going to talk about eruption style, looking at bubble gas content. And then a good rule of thumb is the more bubbles, the bigger bubbles you see, the more eruptive it is. This isn't a perfect science, but it's a start. If your rock has 1 to 30% vesicles in it, that's not very eruptive to slightly eruptive. 30 to 60, moderately eruptive, and over 60, that's highly eruptive. And then the way I would go about this, give 16 to 18 a try, and then you can kind of check your work with 19 to 21. What I mean by that, we have these 3 rocks that we're looking at that all have that kind of hole structure to it. And then we're trying to figure out which one's the basalt, which one's highly eruptive, which one's moderately. So give it a try matching each one down here. But then if we look at 19 to 21, it gives you the percentage of vesicles. So you can figure out like 68%, that would be highly eruptive. So then you can kind of try to find, well, which one is highly eruptive, and you can kind of solve it that way too. And yeah, that's it for all the Volcanoes Lab. So I hope you enjoyed them. And please let me know if you have any questions.